This week and next week are focusing kind of on environmental aspects, particularly on the kind of feedstock production side of things. Okay, and in the labs, you're basically going to learn how to use the simulation models, either the set model or the Century model. So that'll be on the next two Thursdays. The first two Tuesdays now will be again more on kind of the feedstock side of things, and then in not this week, not the following week, and then the third week of this module, Tom Bradley is going to give a lecture specifically on life cycle analysis, more from the kind of fuel conversion side of things. So, the stuff we're talking about now, again, over the next 2 weeks is more on the feedstock. Then the fuels, you'll have a lab then, again, with the Greek model, which you played with a little bit a year ago in the first course. But that's going to be, that laboratory should be targeted a little bit more towards using Greek specifically in your project analysis, okay? And then the following week, the fourth week of this module, I'm going to be gone. I've got a trip in Europe, but John Field is going to have kind of a sort of an integrating life cycle session. It's going to be a little bit more of practical. So he'll give some background material on the Tuesday, but there'll be more sort of working sessions. And so that'll help you begin to tie together, the feedstock, the transport, the biorefining side. And then the following week after that, I think it's the last week of classes, both the Tuesday and the Thursday are devoted to laboratories, for actually working laboratories doing their analysis. So I'll be there. I think John said he would be there to help out as well. I think, I'm not sure if Jenna maybe is going to try to be available too, so you guys can be working. So that's kind of the way it's going to go now for this final month. And then there'll be, of course, the final. So I don't know, any more questions on the, we can talk a little bit at the end, I think, and go through, I can bring up those guidelines if you want to go through and talk about it. I know there were a few questions that I heard back from Mark. Let's see, did this thing pick up anything or not? Laptop. Okay. Oh, it's there. Okay, cool. Just took a little while. Okay, so today and next week we're going to be talking. Well, again, about the feedstock production and looking, particularly this week is kind of the focus on greenhouse gas emissions from the feedstock production. And this is, I don't know if we should get into the lights a little bit. I think that wouldn't be bad. I'll put you guys to sleep. Let's see. Okay. So if we're talking about sustainability, that's kind of what this whole section on life cycle stuff is about. There's certainly an economic and social component of sustainability, and I guess you guys have been working on that. So now we're going to talk about the environmental components of that. I would argue for biofuels that greenhouse gases should be a pretty important thing, because that's really supposed to be one of the major reasons to have biofuels at all, right? Otherwise, we can just do Water, of course, you're dealing with, at least in a lot of the systems, terrestrial ecosystems, water is essential for the feedstock. But so there's issues of both quantity and quality with respect to water use. Again, terrestrial ecosystems, so we're managing those systems to produce something. There are consequences, erosion, soil water relations in terms of soil structure, etc. Other issues that relate to air quality besides greenhouse gases could be NOx, ozone, SOx, particulate matter, things of this nature. Biodiversity, again, how we produce our biofuel feedstocks could have positive or negative impacts on both habitat, ecosystem function for communities in general, but also potentially, charismatic species or something like that, particularly if you're talking about, land use change being involved. And of course, other things like wildlife and hunting might somehow be tied in. Don't know if there was biodiversity, but in any case. And so, various groups and stuff that are looking at the biofuel situation and trying to define what sustainability means are certainly out there. There's this organization. Who's heard of the Roundtable on Sustainable Biofuels? Anybody heard of that? It's kind of an industry. I think it's an industry initiated process, but they also have tried to bring in environmental stakeholders and others. It's a fairly decent group from what I can tell from what I read. And basically what they're trying to do is to get kind of a consensus on on what certified sustainable biofuels really would be. And obviously they want that to try to market successfully their products and also to develop standards for that. I would say to some degree this was maybe inspired from events in Europe in particular that started to come to people's awareness a few years ago that related to biofuels. A particular issue that was fairly thorny. I wonder if anyone wants to speculate on what that might have been, what it still is, although it's kind of led to this idea of certifying the palm oil issue, right? Because Europe said we're going to start producing lots of biodiesel and stuff like that, and of course they can grow a little bit of rapeseed, things like that, but it's not all that great. And then it's like the Malaysians and others come along and say, hey, we got palm oil, we produce, it's a tremendously productive crop. And so initially it was like lots of enthusiasm. Okay, palm oil is a good solution. And then of course it didn't take long when people started looking, okay, what's happening now that Malaysia, Indonesia, Brazil, these other places that can produce palm oil, to meet this European demand, what's happening there? And of course there was a lot of clearing of native forests and planting palm oil plantations, etc. So kind of the European, probably I guess the consumers and the environmental groups said, wait a minute, we need to consider this and is this going to be certified as a biofuel solution for European biodiesel? So it's that the same kind of thing has happened there. So it's happening here. And of course here we've got the arguments about corn ethanol, right? That initially you didn't hear much, and then people get into the details and it becomes quite controversial. So they're really trying to kind of set some standards and really get consensus building on what sustainability is. And so, and they basically got these different principles, so you can see it's kind of all over the board, right? But there are, the things that we're going to be looking at primarily, relating to greenhouse gas emissions, water, soil, air, food security, or at least components that I think you guys are going to be addressing in one way or another, and maybe also, some of these other issues about, rural and social development and land rights and stuff like this, perhaps as well. Okay, so potential environmental sustainability objectives, things like minimizing the bad stuff and maximizing the good stuff. Won't really go through reading that. You guys can look at it yourself. But I think that the key question then is how do you really decide what a product is sustainable? It's a very subjective term, right? And how do you make choices between different competing options that fulfill or don't fulfill these kind of goals, to varying degrees. And of course, that's difficult, right? Because all choices are to some degree subjective, and you've got multiple trade-offs. How much is, and the classic one, right, is what? Is the trade-offs between economics and environmental. So it's great. If you could design something that has very low environmental impacts, very high environmental positives, if it doesn't make money, it's probably not going to happen. So, how much do you have to trade off between economics? And likewise, how much do you trade off between maybe even, greenhouse gas emissions, and maybe that's antithetical to minimizing water use, something like that. So it's, lots of different trade-offs there. And of course, you've already had an introduction in last year's course, and some of you are working with in your dissertation research this idea of life cycle assessment, kind of this full cost accounting, if you will, this cradle to grave sort of a mechanism to evaluate these things. And I'm not going to go into a lot of detail on the LCA procedures, because you're going to get that here, again, a refresher on that in a couple of weeks. But still, I think I think it's useful as you're thinking about what you're going to be doing for your class projects, is to kind of look at the big picture. This is John Field, your colleague from the first cohort. This is a slide that he put together. It looks like it's not quite at the bottom. And it's basically looking at things like agricultural biofuels, and he's kind of enumerated some of the different metrics that you might want to include in in your life cycle assessment. And so a big part of the the exercise is you guys are going to be using century day set modeling to get a lot of the answers for this. Some databases and other things, and Greek model for this part, and we're going to kind of do some simple approximation of the transport situation. But essentially try to compute these different metrics and the interactions between those in a whole system for your biofuel production. And then, as you noticed, in the guidelines, we talked about, okay, speaking specifically about the feedstock production, it turns out that a pretty substantial part of the total greenhouse gas footprint, and probably arguably the major part of the sustainability footprint of biofuels, is related to the feedstock production. Okay? And so it's a big, important component, but it's also one that is subject to how you manage. What choices do you make? How do you produce the biofuels? Everything from your fertilization practices to the choice of the land base that you're going to utilize to produce that biofuels. So in doing these kind of life cycle assessments, you can line up multiple alternatives, kind of projects and